Okay, so we're going to talk about learning trigonometric functions of general angles. Now, when they say general angles, they just mean like any angle. So, for example, if your angle was bigger than 180 degrees, it was down here at like 210, 220. It's a little complicated to think of like, well, what is the opposite side to that angle? There is nothing opposite, right? There's nothing straight out from this angle. There's no adjacent, there's no hypotenuse. It's kind of confusing when you look at it that way. If you imagine it more like there's a right triangle in here that you can make, then as we go past 180 degrees, we are still looking at a right triangle. We're just looking at one that's kind of down in this bottom left, third quadrant. So I want to remember that all of our values for these trigonometric functions, all of the outputs come from using right triangles. So we need to kind of imagine where in this image a right triangle would be. So right here, it would be, in this bottom left-hand part. So what they're saying is that you can find values of trigonometric functions for angles greater than 90 or less than 0 when given a point on the terminal side of the angle. So if we know some point along this line, then we should be able to figure out all of our different ratios. So they're saying let theta be an angle in standard position and let the point P at the coordinate xy be a point on its terminal side down here. By the Pythagorean theorem, r, the hypotenuse, should equal the square root of x squared plus y squared, where x is the distance right here on the x-axis, y is our distance right here, right? So a squared plus b squared equals c squared. To get c by itself, you do square root of both sides. So we get r is the square root of x squared plus y squared, where r is the distance from the origin to point P along the terminal side. Using the coordinates point P and R, the six trigonometric functions of theta are defined below. So sine, your opposite over hypotenuse, your opposite would be the y-axis coordinate, and your hypotenuse would be r. So sine of theta would be y over r. Tangent of theta, TOA, opposite over adjacent, would be the y value, right, the height of this point, over the adjacent side, the x coordinate. So it'd be the opposite side over the adjacent side, y value over x value. Cosine, ca, C-A-H, would be adjacent over hypotenuse, so that'd be the x value over the r. And then the rest of our trig functions follow from there as they're those flipped over versions. There's a few of these where they say x can't equal 0, y can't equal 0. All right, that's just based off what's in the denominator. So we're assuming that our functions should always produce outputs that have some defined nature to them. If the terminal side of an angle, theta, in standard position coincides with one of the axes, the angle is called a quadrant angle. Since r is the distance from the origin to the point P along the terminal side, if theta is 0, right, so if we have both of our arrows, the initial arrow and the terminal arrow, both pointing along the x-axis, well, then our distance r will just be however far out our point is on that x-axis. If we're at 90 degrees pointing up here, then our r will be whatever our distance is on the y-axis. If we are at 180 degrees somewhere out here, well, then it's going to be the absolute value of x, right? We might be back at -5, but the distance itself is not a negative number, it'd just be 5. Same thing for if we're down here at 270 pointing straight down, well, our r will reach out with a length that goes the same distance as the y-axis value. So it'll just be the absolute value of y. If we're down at like -7, then the length of that r would be 7. So those are called quadrant angles. Okay, so we'll give that a try. Give those ideas a try in example number 3 in the next video.